done the science side, you've heard about our research, and now you're going to hear about a bit more about the technology side of STEM. So I'm not sure, do we go straight to them or do we go back to you, Susie? What happens next? We'll see.
Straight over, that would be marvelous.
Brilliant. Okay, so straight to the technology in space panel.
Brilliant. Patricia, can you hear us?
Yes, I can.
Perfect, perfect. So now we are going to lead into our technology in space panel. So Patricia, I think we've waited. We are now very much ready for you. Sorry about those slight technical difficulties. So Patricia, it's over to you and your excellent panel.
Oh, brilliant. So welcome everyone to today's Technology in Space panel session. I'm very, very excited to be involved in Mars Day because Mars just happens to be my favorite planet in the entire solar system. In fact, I have got plushie Mars sitting right over there, which is one of my favorite plushie toys that I have. And I hope that everyone's had a brilliant Mars Day so far, and that it's piqued your curiosity and it's got you really excited about considering a career in STEM, in astronomy, or in space exploration. So we've got some brilliant panel members in our session today, and I'll be introducing them to you all very, very shortly. But I thought I'd just give you a bit more information about myself and what I do. So I'm Patricia Skelton. I'm the Senior Astronomy Manager for Education and Outreach at the Royal Observatory, Greenwich. So what it means is that I look after formal learning programming, or in other words, things involving schools. So any school programs, any school visits that happen at the Royal Observatory, Greenwich, that's what I look after. And the thing that I love most about my job is that I get to talk about astronomy and space exploration every single day. And I get to share my passion for those subjects with everyone who visits the site. So that's sharing it with school groups or indeed members of the general public. Now, I wasn't always a science communicator because that's basically what we do at the Royal Observatory Greenwich. I started my career as an academic at a university. So when I was in secondary school or high school, so I grew up and studied in South Africa, I knew that I wanted to go into a career involving science in some form, but I wasn't quite sure what I wanted to do. So in secondary school, of course, we had to pick subjects about, what we planned on studying, especially if we wanted to go to university. So I knew from the beginning I wanted a career in science. So I took all the science subjects. So I took physical sciences, natural sciences, including biology, chemistry, and of course, mathematics. But when I finished secondary school, it was quite interesting because I wasn't quite sure what I wanted to do. So while some of my fellow friends and students immediately embarked on careers, sort of their study paths at universities, I opted to take a year off because, as I said, I wasn't quite sure what I wanted to do. But during that time, during that period off, I got to think about things that made me really excited, and I realized I quite liked astronomy. So after that year off, I then enrolled at a university to start a bachelor's degree with majors in astronomy and physics. Now, something else that differs is that I did not go to a residential university. I opted to study via distance learning. So I actually enrolled at the University of South Africa, which is a distance learning institution. So basically the same as the Open University. And I know that's very strange. Not many people necessarily go down that route, especially if they have the opportunity to go to residential university. But I quite like studying on my own. There was a particular thrill about teaching myself, various concepts. I still remember the day I learned how to do integration, and that was a very exciting day. Needless to say, some people in the household didn't agree with me when I was running around saying, I know how to integrate. They were like, that's great. But for me, that was a really good moment. But yeah, so I studied at University of South Africa. And when I embarked on my honours degree, which is sort of the next step up because the degree structure in South Africa is slightly different. You'd normally do a bachelor's degree, then you go honours and then into master's. I opted to do an honours degree in astronomy. And then I was very fortunate because I was then employed by the university as well. So while I was studying my honours degree, I was employed as a student assistant. So that meant helping out with running the astronomy practical sessions and also sort of tutoring students if they ever emailed us with queries. I then completed my honours degree and started a master's degree in astronomy. And while I was doing my master's, my employment at the university changed to becoming a full-time academic. So I then started as a junior lecturer and I taught undergraduate astronomy modules. So I did that for a very long time. So in all, I was involved with teaching at the university for about 10 years. And I really enjoyed that. I really enjoyed teaching students. But I realized that there was something I was missing during that time. And I realized that I really, really wanted to do a bit more outreach, but more engagement with the public. And although I had some opportunities to do that as an academic, it wasn't something I could do on a daily basis. The other thing I wanted to do was move countries because I'd always wanted to move to the United Kingdom. And I looked for job opportunities. And there were two things I was very sure about. I knew I was going to work either at the Science Museum in London or the Royal Observatory in Greenwich. Because of the two museums that I have visited for a very, very long time. Anytime I was across in the UK for a holiday, I went to visit one of these museums. And I was very lucky that an opportunity opened up at the Royal Observatory Greenwich. And that's where I started. I managed to get a job as an astronomy education officer. And that was brilliant because it meant every single day I was working with schools or the general public, and I was teaching them astronomy topics or taking them into the planetarium, which is a brilliant piece of technology. It's a cosmic tour bus because you can take people anywhere in the universe inside a planetarium. So you want to go to Mars, we'll take you to Mars. You want to go to the edge of a black hole, we'll take you to the edge of a black hole. It's so, so much fun. And there's something amazing when you're inside the planetarium with a group of people and you take them to see all these amazing things in our universe and everyone goes, wow. And they get so excited. And that's what I love doing about my job. That's what fills me with happiness and makes me go back into work day after day because that's the part I really, really enjoy. And I hope to continue this amazing work and have more opportunities to basically nerd out every day. It's what makes me happy is I can go in and I can talk to people for hours about things that we all get very excited about. And one of the things that I love is the fact that when amazing things happen with space exploration, so for example, things that are happening with Mars, we get to put that up in our planetarium and share that with people too. So there's lots of amazing things that we do. And so that's my journey. That's how I ended up at the Royal Observatory Greenwich. So I started off as an academic and ended up in science communication. But today's panel members are doing amazing things as well. And they've also got interesting journeys that have led them to where they are today. So I think it is time for us to meet our first panel member. So I'm going to introduce you all now to Emma. So Emma, if you could let everyone know who you are and what you do, that would be great.
Great. Hi, everyone. Yeah, so I'm Emma. I hope you can all hear me well. So I'm a planetary geologist. So that means that I study rocks in space. So I'm a PhD student and my research is focused on studying rocks at Mars rover landing sites. So I try and understand what the environment of Mars was like billions of years ago. I use technology every single day in my job, and I use remote sensing to look at images of Mars from satellites. So I use software on my computer and my laptop and analyse these images to look closely at the rocks on the surface. So there are satellites all around Mars that carry lots of different and really clever instruments that I would like to introduce you to a little bit more today. And they help us to see the planet in different ways. So I'm going to share my screen quickly and show you my favourite view of Mars. So Patricia, if you cannot see this, please let me know. Oh, I can
confirm we can see it.
Great, fantastic. So this is an elevation map of Mars, and it's made from a really clever instrument called the Mars Orbiter Laser Altimeter, but that's a bit of a mouthful, so we normally just call it MOLAR. So this uses lasers pointed at the surface of Mars to see the high points and the low points. So here we can see the high points in red and yellow. So this is a volcanic area called Tharsis. And we also see another volcanic area here called Elysium. We can also see the low areas. So Hellas Basin is a big impact crater here in the Southern Highlands. So I use this topographic data every day in my job to look at the topography, the high points and the low points of the study area that I'm currently looking at. So another way we can look at Mars is in infrared data. So this allows us to see what type of rocks are on the surface of Mars and what minerals are there. So the colourful parts of these maps show areas with high levels of hydrated minerals. So that's just a fancy way of saying that the rocks interacted with water at some point in the past. And these are really interesting places to look at if we want to think about the habitability of Mars and if there was ever life on Mars. So we basically use lots of different maps and look at the most interesting places on Mars to see whether these could be suitable places to send Mars rovers. So you might recognise a couple of these names on these maps here. For example, Jezero crater, this is where Perseverance is here, and Curiosity is in Gale crater. So this is what Gale crater looks like today, a very dry desert landscape, and this is where Curiosity rover landed in 2012. But if you're a planetary geologist and have had a few years of training, you might be able to decipher from this image that there is actually evidence of past water flow. So up here you can see a channel coming into the crater, and you can also see a really small one here as well. So this showed scientists that billions of years ago, Gale crater might have actually looked something like this. And this is one of the main reasons that this area was chosen to be the landing site of Curiosity rover. So Curiosity has spent over a decade on Mars. It takes the most amazing pictures and sends them back to Earth so we can see the rocks in much better detail than we can from satellite images. We can then also see if the hypothesis that we've made from the satellite images are true. So the rover has a drill and it can drill down into the rock and analyse this rock dust in an onboard chemistry lab. So we can learn so much from having Mars rovers on the surface. As I use remote sensing data every single day, I thought it was only fitting to show you a couple of my favourite images. So this is from a camera called HiRISE, which takes really high resolution pictures of Mars. And this is actually Curiosity rover here, which I think is fantastic. You can see the regional geology here, and it just shows how tiny it is in comparison to the landscape. And in this image here, this is Curiosity. You can even see the rover tracks the rover has made as it's been driving across Gale crater. So I think this picture really shows how good technology is now and how it's able to show us so much about Mars, even from my little office here on Earth. So thank you so much, Patricia. I'll hand it back to you.
Oh, brilliant. Thank you so much, Emma. I have to say, it's amazing how far we've progressed in our studies of Mars, thinking that at one point we were restricted to just what we could see through a telescope. And yeah. I mean, and now we've got a helicopter flying around on Mars. I think it's absolutely amazing that we get to see this every single day. So it just makes me so very happy. But no, it's amazing work that you do. It's very exciting.
Thank you.
Yeah, let's hear from Eddie. So Eddie, if you could tell us a bit more about what you do every day.
Sure thing. Thanks, Patricia. And hello, everyone. Great to see you all. I hope you've had a great day so far, and I hope that you continue to enjoy Mars Day 2023. So my name's Eddie Ross. I'm an astrophysicist and a space systems engineer. So I have a background where I did some research to obtain my PhD, which is all around the sun's magnetic field and how that impacts on the Earth. And hopefully some of you most recently have been able to see some of the aurora borealis down in the UK where you live in the night sky, because the sun's been quite an active period most recently. So I have a background researching the sun. And I also have a background creating technologies that go onto satellites that ultimately make their way into space. So most notably making imaging sensors that have been to Jupiter and Mars, and also developing technologies that take on the principles of quantum mechanics to create next generations of sensing technologies that will hopefully start to be used in space over the next 10 to 20 years. But at the moment, I'm not working on any space projects. I'm currently working on developing autonomous boats for the French and British navies. But despite that being away from the space sector, it still uses space technology. So for instance, we use global positioning systems or global navigation satellite systems, so GPS or GNSS. So using those space technologies to try to help us understand where we are when we're navigating our boats around the oceans. So I've got an academic, so research background and an engineering background, but prior to my current role, I was also helping academics and industry people to work together, which is often a challenge. One of the biggest challenges in the space sector is trying to get the research people to talk to the industry people, the ones that actually start to make things. And prior to my current role, I was working at a company called the Satellite Applications Catapult, whose great ambition is to try to grow the UK space sector by the end of this decade. And they're doing a brilliant job, and there's lots of thriving opportunities in the UK space sector. So hopefully there'll be plenty of opportunities for you guys once you've finished your school and you start to take jobs in the space industry. And finally, I'll just mention that I also volunteer on the Royal Aeronautical Society's Early Careers Subcommittee for the space sector, which tries to help support people that want to try to get into the space industry. So when you transition out of full-time education and start to get into space sector jobs, which I'm sure you all will do following today, just know that there are a number of societies that you can join, and they will be able to try to help your career path in the future. So I'll pause there for now and wait for future questions. Thanks, Patricia.
Oh, thanks, Eddie. And it's actually an interesting point that you raised about technology, because sometimes technology we develop for use here on Earth can be applied to spacecraft and we employed elsewhere, and the opposite is true. Technology developed to help us study extreme environments, or anything developed for spacecraft, often end up being used in some form here on our home planet as well. So there's this very important part that technology plays all around. And our final panelist is Bryony. So Bryony, welcome. If you can tell us a bit more about what you do.
Hi, Patricia. Thanks for having me. I hope everyone's enjoying their Mars Day. So I'm Bryony, and I'm a PhD student as well at the British Antarctic Survey. And I use space technology to actually study the Earth. So similarly to Emma, I use data from satellites and a laser altimeter as well. In particular, this one here, which is ISAT-2. But instead of pointing away to Mars, this one's pointing down at Earth. So it uses lasers that it fires down to the surface of the Earth and records the time it takes to bounce back. And then you can map the surface of the Earth every kind of 30 centimeters along track. So it's really, really high resolution. It's amazing, amazing data. And I use this to look at how the surface of the ice sheet in Antarctica is changing. So in particular, how it's impacted by warming atmosphere and ocean as a result of climate change. So this satellite was launched in 2018. And so we now have a 4 or 5 year record of surface elevation change from this particular satellite in Antarctica. And we're interested in seeing if the ice sheet is lowering in its surface. It indicates to us it's losing more ice mass to the ocean and contributing to global sea levels. So we as scientists in the kind of glaciology community are really interested in understanding how the ice sheets will respond to climate change so we can better predict future global sea level rise, which will obviously impact communities all around the world. And it's vital that we use the technology in space in order to study this, because Antarctica is so vast and so remote. It's double the size of Australia, so it would be really impossible to measure it by people going down there or having kind of even aircraft flights over. You could not possibly cover the whole of the continent in the resolution you need. And satellites mean that we can get up to daily images and data sets of how the ice sheet is changing. So yeah, space technology is vital for the study of climate change, in particular in the polar regions. So yeah, I'll finish there and hand back to Patricia.
Brilliant, thanks, Bryony. And you've touched on a very important point there, is just how vital satellites are in monitoring changes that are taking place here on our home planet. And we only have to look at two other examples in the solar system of where climate change has, radically transformed planets. And so obviously it's very important for us to study what's happening on our home planet and see those daily changes. And I suppose there's also, a nice little contrast. If we think about Mars, for example, we have those orbiting satellites that are tracking Mars as well. They're taking those images, they're looking at changes happening on the surface of Mars. Just off the top of my head, you've got Mars Reconnaissance Orbiter taking amazing pictures, and you're seeing all these changes happening from meteor strikes, avalanches. It's so much fun. And we've actually got some really great questions that have come in from the students watching. So Emma, one of the questions has been directed to you, and so they'd like to, it's from BHA Year 4. And they would like to know, what types of rocks did you find on Mars?
Yeah, great question. So I'm not sure how much they will know about geology, but there are three kind of main types of rocks. So you have igneous rocks, so those are volcanic rocks. You have sedimentary rocks, which are rocks that formed in water or desert environments. And you have metamorphic rocks, so those are igneous or sedimentary rocks that have been changed. So for example, when you build the mountain belt, you could squish the sedimentary rocks together and form a new type of rock within the mountain. So on Mars, we find sedimentary and igneous rocks, and the ones we're most interested in are the sedimentary rocks, because those are the ones that basically tell us that water might have been involved in their formation. So for example, where Curiosity rover is in Gale Crater, you have a whole different sequence of sedimentary rocks that can show basically how the lake changed and dried up over time and how the environment changed billions of years ago. So yeah, the ones we're most interested in are the sedimentary rocks on Mars.
And it's great that that question was asked, because in a sense, the rocks are telling us the history of Mars. So we're looking at it, and that's where, if you think about it, we're seeing not just telltale signs, as you show brilliantly, where you can see how water's carved its way along the surface of Mars and left those imprints, but it's looking at how it's actually interacted with the rocks on Mars. Yeah,
absolutely, especially when you're looking at rocks that are potentially billions of years ago. It's really, really cool stuff, and yeah, very, very lucky to do the job that I do.
Oh, that's brilliant. And we've got some other important questions, and there's one that I promise I will ask. I'll probably keep this one till the end, because I'll want an answer from everyone, and it's a really good one, so I'll hold on to that one. But a question for you, Eddie, actually, maybe, because it's about the space industry and careers. So what type of careers are available in the space industry, specifically in the field of technology? So yeah, what could students think about in terms of potential future careers?
Yeah, that's a brilliant question. So there's a kind of a more traditional answer that I'll give first, and then I'll try to bring it to a kind of more modern day spin. So the kind of more traditional answer that people tend to think about when they think of space technology careers are kind of one of three paths. So I suppose a scientist, an engineer, or a technician. So the scientists are the ones that are kind of showing the fundamental principles of the technology. So kind of using the laws of science, so biology or chemistry or maths or physics, let's say, and just showing fundamentally how this new technology might work. And the engineers are the ones that go from those fundamental principles and design and develop the actual piece of technology that would be built and manufactured. And then the technicians are the ones really that are on the front lines. So they're the ones that are taking those engineering developments and from kind of the constructions of the raw parts, putting all of that together, building and then testing and assembling the technology. So they're the kind of three traditional elements. But I do want to let everybody know that it's not all about science and engineering when it comes to the space sector. So for instance, if you're interested more in design, we've seen quite a lot of technology bringing in design principles that the space sector started to adopt. So a lot of people are aware of how Apple have really revolutionized the mobile phone industry, just to name sort of one of those companies. But Apple are the ones that are really synonymous with being able to kind of show how things can be done differently and bringing in kind of user-centric. So making sure that humans are happy with the things that they're using. And for instance, SpaceX have really started to push the boundaries, and they're doing that in some of their capsules. So the Dragon capsule is completely different to what the Apollo capsules used to look like back in the 60s and 70s. So they're really bringing in some kind of design principles, and I just wanted to kind of put across that it's not all about science and engineering, even though that is ultimately where a lot of it goes down. When you're developing technologies, there's all sorts of design principles that you might want to consider. So if you come from more of a kind of art or humanities aspect, there's that to think about. There's also, when you're developing new technology, there's all things around law, kind of who owns the IP. Do you want to protect your IP? So there's all sorts of questions around law. And then when you're developing technology as well, ultimately it's businesses that are doing that. So you have to think around the economies of creating the technology. So if you're interested in more business type roles or finance type roles, there's all of those things that have to be considered as well. And fundamentally, all companies tend to need to have people that manage people as well. So you can be a manager, or you can be in human resources and look at how people within the entire business are being looked after. The IT specialists that then make that business run. So there's all sorts of different types of careers when it comes to developing space technology, not just those ones that come to the front of the mind first of all. There's all sorts for all types of people, getting into them through all types of pathways as well. So I hope that answers the question, even though ultimately I think I'm saying there's probably too many roles to list and too many ways to get into those roles to list.
Well, that's what makes it so great, isn't it? Is the fact that it's so broad. There's so many things that you could potentially do. So, we might just think technology, but we don't. If it's when you start to unpack it and you think about all those different strands that are potentially involved, which is great. And it's something that I think when I used to talk to students as well about it, is when we think about things, when we think about designing spacecraft and that, for example, you've got the people who design it, you've got the people who build it, you've got the people who write the software for it, you've got so many different strands, and they all mix together quite well. So you have this lovely merge of all these different fields contributing to creating something amazing. Now, what would be lovely to talk to the three of you about is how you ended up where you are today. So what directed you down this path? So Bryony, how did you end up down this path of looking at the Earth and studying climate change?
Yeah, so I actually came from a background in geography. So I did my undergraduate degree in geography, and I kind of came to do that. It'd always been my favorite subject throughout school, as long as I can remember. It's been my favorite subject, and then I did A-levels in geography, physics, German, and music. So like a really wild combination of subjects. But I just did the ones that I loved the most. I love physics as well. That was like my second favorite. And so it's quite funny now that I'm kind of working right at the interface between physics and geography. But after my degree, where I'd like developed more of an interest in the physical side of geography and particular glaciology. I was at Durham and they had a really great glaciology department. I definitely didn't want to carry on studying after, so I took a year out and I went traveling and working in New Zealand for a year, and I actually found a course at a university for a few months doing Antarctic studies. and it included a field trip to Antarctica, which was incredible. And I was lucky to get a place on that. And that was a really transformative experience, like personally and academically, I guess, and really, really inspired my passion for Antarctica in particular. I then went on, after a break in studying, to do a master's in geographic information systems and Earth observation, which is a bit of a mouthful. But that really helped develop my coding skills, and I was exposed to so many different types of satellite data and how to process it and lots of different applications. And I still realized that Antarctica was my passion. So when I found this PhD, it kind of made a lot of sense. It kind of brought together everything I enjoyed. And yeah, so here I am 3 years into that. Yeah, still don't know what the future holds, but that's the fun of this kind of career. It can go lots of different directions.
Well, that's great. And I think that's a really interesting for students to hear as well, is that you can end up in the space industry coming in from a different path. So maybe not so much a traditional physics and mathematics and all and that, and going straight down that path. But Emma, is your path similar to Bryony's, or do you come in on the more traditional path?
Yeah, my path is actually really similar to Bryony's. So all throughout school, just like Bryony, I just loved geography. So physical geography was my favorite thing. In particular, volcanoes. That was like my favorite thing in the world. So I was like, I want to be a volcanologist when I'm older. That just makes sense. So I went to Lancaster University and I did a degree in Earth and Environmental Science. And somewhere along the road, I found out there were volcanoes on Mars, which blew my mind. And I was like, that's what I have to study for the rest of my life, volcanoes on Mars. So I ended up doing my undergraduate dissertation on volcanoes on Mars. And then I went to do a master's degree at UCL in London, and that was on planetary science. So that kind of opened the door into a whole different world, and yeah, really took my focus to Mars in particular. And then I managed to get a PhD at the Natural History Museum and Imperial College London, and I'm in my second year doing that now. So yeah, still absolutely loving it, but definitely not the traditional route. So my A-levels were actually geography, biology, and English literature. So not traditional science at all. And yet I work on Mars every day. So yeah, you really can just do what you love and still end up in a job that you absolutely love.
Well, to be fair, I mean, Mars is really good for that. I mean, you picked a place that's got Olympus Mons. I mean, hands down, it's amazing. Maybe we'll have a chat post this session about your thoughts on whether Olympus Mons is still active or not. We can.
Oh, definitely.
We can have a post-session chat about that. And if someone wants to ask a question, so there we go. Maybe someone will slip it in. We can talk about it in the session. But Eddie, what was your path, and how did you end up in your career?
So for me, I followed a fairly boring traditional route into the space industry. But maybe I'll start the journey with saying that I never wanted to work in the space sector. I think when I was back in school, I either wanted to go into graphic design or I wanted to go into music journalism. So nothing to do with space at all. But I remember when I was doing my art GCSE, I painted a picture for my final exam of a satellite melting near to the sun, because I thought that it looked really cool and it would challenge my painting skills. But then who would have thought that wind forward a few years, I basically followed my friends into their GCSE choices, and they all were good at maths and physics, so I just followed them along. And then I followed them into their A-levels, which was also maths and physics, and I decided that I found art at that A-level stage a bit too difficult, so I just decided to fall back on the stuff that I was kind of okay at, which was the maths and the physics. And then I decided one day that I had watched loads of sci-fi movies and thought, I'm really liking all of these sci-fi movies. I like the looks of sending stuff into space. Maybe one day it would be cool if I sent something into space. How do I get there? And I thought I'd keep it nice and broad, so I did physics at university. And after I did physics at university, I decided I still wanted to do more space stuff, so I did space engineering as a master's degree, and then went on to my space systems career. But I did go back into the physics research. As I said, I got a PhD in solar physics, where I just wanted to kind of probe my understanding of data science and the understanding of how the sun works a little bit further before returning back into engineering roles in the space sector. But ultimately, yeah, for me, it was never the plan. I just kind of meandered towards the space sector because I was okay at maths and physics, and then one day, after watching too many sci-fi films and reading too many sci-fi books, decided that maybe that's what I want to do with the rest of my life.
Well, I also have to say that for me, science fiction did also play a very important part in getting me interested in astronomy and space exploration. For me in particular, it was Star Trek. That's what I grew up on, and specifically Next Generation. That's what really got me excited about space exploration. But I think, thinking of all the questions I've been asked over the years, something that pops up quite a lot is, what advice would I give to students who are interested in, going into a career involving STEM, or interested in astronomy or space exploration career? And so I'll get your thoughts on this as well. And there's probably the traditional advice as well, but something I've always been keen to stress with students is never stop reading, never stop learning. There's so much information that's available today. The internet's a brilliant thing. So anything you're curious about, from any planet in the solar system, any space exploration, you can find websites about spacecraft design. It's amazing what information is out there. And, there's brilliant books and also lots of lovely online lectures and stuff that you can watch. So that's one of the things I've always been keen to stress, is that there's so much information out there. But what advice would you give to students if, they came up to you and said, I want to do what you do. How do I get there? What should I do? So Bryony, what advice would you give to students?
I'd say, as a general point, that there's no major rush, and it's important to take time to realize how you like to work and what you like to do, what motivates you, because that's the most important thing for a career, I think. Day to day, being motivated by the work you do. So yeah, take the time to do, I don't know, even work experience, opportunities that come up, working abroad, traveling. I think it gives you the space, especially straight from school. It can be quite suffocating in the academic environment, so it's good to take some time to work it out. But on a more practical notice, I would say that all my colleagues I work with, everyone has to code, and so learning to code is a really, really, really valuable skill. And it's a bit of a steep learning curve, and I was really scared to do it at first, but it's really satisfying, and yeah, I would just really recommend it, because everyone needs to do that now if you're in this kind of in the science side of the sector, I would say. So yeah, it's fun, I promise.
Eddie, what advice would you give to a student?
So probably just kind of similar to Bryony, but keep asking lots of questions. I mean, there's always new knowledge to be gained. I would say that I'm always learning. No matter how many accolades you might pick up, there's still something new to be learned. So you're never quite the expert. There's always more to learn. I'd say similarly, try to find internships or work experience wherever you can. So within the UK, there's lots of fantastic schemes at the moment, and there's lots of people trying to promote these fantastic schemes as well. So at the various levels throughout your education, there's opportunities to try to get work experience. So I'd absolutely encourage you to talk to your teachers, talk to your friends, talk to your family. Just somebody might know somebody who can give you that opportunity, and just search around on the internet. There's lots of great websites that are trying to promote these opportunities, and there's more and more work going into trying to promote those opportunities as well. And as I said, know that there are multiple ways into the space industry. There's not just that kind of one golden thread where you just go, you do sort of engineering at university, and that's the only way to go to be working in the space industry. I'd say no. There are various ways to land into the space industry.
Oh, that's brilliant. And Emma, what advice would you give a student?
I think I would say that when you're at school, you should pick the subjects that you love. That's obviously going to kind of dictate the direction that your career goes in. But if you had told me when I was taking English literature for A-level that I would be working on Mars as a job one day, I would have never believed you, but it's actually been a really vital skill and I can write really well now because of it. So definitely pick the subjects that you love rather than the ones that you think you should be doing. And then also when it comes to Mars, I would say follow along with the mission, like literally follow them on social media, see what things are up to. There's so much data available to the public, so many really cool images that you can follow along with, and yeah, just see which parts of them that you like.
Brilliant. Well, I'm also keeping an eye on the time because I know our session is almost at an end, but I did promise it was a very important question that I was going to ask the three of you. I hope you will give the right answer. I feel like there is a right answer to this, but maybe they won't be. Maybe this will be quite controversial to end the session on. But we have a question about what are your favorite planets in the solar system? So I already said mine is Mars. So Eddie, what's your favorite planet in the solar system?
Oh gosh. So this is where I really show my true colours and say that I prefer the sun to the planets. But if I do answer the question, I'm also going to be really boring and say that it's the Earth. I have great love for a lot of the other planets in the solar system, but there's so much going on Earth that I can't say that I love another planet above Earth.
Which we go to Bryony now. Bryony, what's your favorite planet?
I'm also going to be quite boring, and despite my Saturn earrings, if you see them here, I'm going to also say the Earth. Yeah, it's just such a varied, amazing planet, and it gives us life. So.
And now, Emma, up to you. Are you going to bring it back to Mars, or are we going to end controversially? I'll be outvoted on this. Yeah.
My favorite planet is definitely Mars. It's just, yeah, it's incredible. I get to look at the best and most amazing pictures every day. It's such a gorgeous planet, and yeah, the missions there are just sending back such incredible data. It's Mars.
And that's the right answer. So, and as you can, my dog agrees with that, so she's just about to start barking. But with that, just keeping an eye on the time, I think we have to end today's session. So I just want to say a big thank you to our panel members for today for a really wonderful discussion. And thank you to our audience who submitted some brilliant questions too. Sorry, we didn't get around to answering all of them, but I'm sure someone will be able to give you some answers to those questions. Just so that everyone know that your next session will be about engineering in space, and that will be starting very shortly. So make sure that you stay on this link. But from us, I think that's a big goodbye, and we hope that you enjoy the rest of Mars Day.